Okay. Okay, so this is another Kirchhoff loop question, and it's asking what is the current in each resistor. So we've got, now I'm just assuming, although it's not really sketched out like here on the question, that they must match up or link up, otherwise I'm not certain how to do it. So there's 15 ohms, 12 ohms, and 20 ohms. And this is R1, R2, and R3. Okay, so one thing that I will note here is when doing a Kirchhoff loop question, you do want to not only assume the direction of current, but make sure that all the loops start and stop at the same position or the same point. So mine are starting from this top right corner and ending back up at the top right corner. So there's going to be my two loops here. That should be sufficient to get all these. So if I do my first loop, so this is 12 volts, this is 9 volts. So my first loop, I'm going to start here. I gain 12 volts, and then I lose I1 times 15 ohms, and then I come around and I lose an I2 times 12 ohms, and then I lose 9 volts. Okay? And then for my second loop, I gain 12 volts, I lose my I1 times my 15 ohms, I come all the way down here, I lose I3 times 20 ohms, and then I come back to 0. Okay. And then my current is splitting at this split point, and so my I1 is equal to my I2 plus my I3. In this question, it doesn't matter. I'm solving for all three currents, so I need all three of them. So I'm just going to, first of all, make sure that I am following along. And I believe I am. Okay. So then I'm going to use I2 is I1 minus I3 to simplify. So I'm going to put this into my second equation. So my second equation becomes 12 volts minus I1 times 15 ohms. No, I'm not going to put it in my second equation because that doesn't make any sense. Sorry. I guess I'm going to put it into my first equation, sorry. So my first equation, not my second. Okay, so my first equation, first of all, I'm going to remove that 9 volts, so 3 volts minus I1 times 15 ohms minus I2 times 12 ohms equals 0. So then it becomes 3 volts minus 15 I1. I'm just moving that to the front so that it's a bit less in the way. I1 minus I3 equals 0. And this becomes 3 volts minus, so minus 15 minus 12 is minus 27. And then plus 12 ohms I3 equals 0. Okay? And now my second equation is 12 volts minus 15 I1 minus 20 I3. equals 0. And I'm going to go ahead and actually multiply this whole thing by 5/3, actually by minus 5/3. And the reason I'm going to do that, and the reason I can do that, is because it all equals 0. But this is going to turn my first equation into 5 volts minus 45 ohm I1. Minus 5 volts plus minus 20 ohms I3 equals 0. And then I think it's fairly obvious why I did that now, because I'm going to take 1 and I'm going to minus 2. So I'm going to take 1 and I'm going to subtract 2. So I get minus 5 minus 12. I'm going to take 2 and minus 1. That makes more sense. And so I'm going to get 12 minus a minus 5, which is plus 17. I'm going to get minus 15 minus a 45, which is minus 60. And then the 20s here will cancel. And so then my I1 is just 17 volts over 60 ohms, which is 0.2833 amps. Okay, so now that I've got my I1, I can plug that into either equation to get my I3. So I'm going to use my second equation. So I've got 12 volts minus 15 ohms times, I'm just going to use 17 volts over 60 ohms because that way I don't have any rounding issues, minus 20 I3 equals 0. So now I can rearrange this and say that I3 is 7.75 volts over 20 ohms, which is 0.3875 amps. And then now my I2 from above is I1 minus I3, which is 0.2833 amps minus 0.3875 amps, which is minus 0.1042 amps. Okay. So there's my I2. That's the same I3, and that's the same I1. Okay. So just as a note as well, I1 and I3 came out positive, meaning that the current direction I assumed in my Kirchhoff loop was correct, whereas I2 comes out negative, meaning that this current actually goes this way. Or the current I assumed was the wrong direction, so the current actually travels this way in this circuit, or in this line. Whereas the other two, the directions were as appropriate. Okay, so this looks good. So solution is correct.